In this video, we're going to look at some examples of how to apply the chain rule. Our first example, f of x equal to the square root of 5x squared plus 1. So in this function here, I have a quadratic function, 5x squared plus 1, which is inside of a square root function. And so that's a composite function. Those are the types of functions where I need to apply the chain rule. Now I'm going to set this up with a chart, kind of like how we did in class. I have something being square rooted, and remember when we are going to take a derivative for a function that involves a square root, we need to rewrite that as an exponent. And so I have something to the 1/2 power. That's my outside function. And then my inside function is the 5x squared plus 1. So I'm going to do the derivative of the outside function first. So that's going to be 1/2 times something to the negative 1/2 power. And then the derivative of 5x squared plus 1, that is 10x. Now the something over here in my first function should be 5x squared plus 1. And so my derivative is I'm going to take these two derivatives and multiply them. Now when I multiply them together, I'm going to do a little simplifying. I have this 1/2 out here that I can multiply by the 10. And so that turns into a 5, and then of course the x is still there. Now my 5x squared plus 1 here is being raised to the negative 1/2 power. That negative part of the exponent is going to put 5x squared plus 1 into the denominator, and then the 1/2 power means square root. And so my final answer looks like this. This is my derivative, f prime. Let's look at another example. Let's see. Y is equal to e to the 5x times cosine of x squared. So here I have a product of two functions, an exponential and a cosine function, but each of those functions is a composite function because I have e to the 5x, so that's a 5x inside the exponential function, and then I have cosine of x squared, so x squared is inside the cosine function. So this is going to be a little bit more complicated. I need to use my product rule as well as the chain rule. So remember with the product rule, we're going to look at this as f times g. So e to the 5x, that's going to be my f. G is the cosine x squared. What I'm going to do is find these two derivatives first. Find f prime and g prime first. So here's f prime. I'm going to do the little chart again. And my outside function, if I'm looking at f, it's e to the 5x. The outside function would be e to the something, and the something is 5x. So then I'll do the derivative. The derivative of e to the something is e to the something, and the derivative of 5x is 5. And then the something here is 5x. This should go into the something. So my f prime is equal to 5 times e to the 5x. All right, now let's find g prime. My g is cosine of x squared. So the outside function there is cosine. I have cosine of something, and that something is x squared. So first I'm going to take the derivative of cosine, which is negative sine of something, and the derivative of x squared is 2x. And then my x squared needs to go in here. So g prime is equal to negative 2x sine of x squared. So now that I have f prime and g prime, let's go back over to our original function and do the product rule. Let's see, I think I'm going to have to go down to the bottom of the screen. All right. dy dx is equal to, and my product rule is f prime times g plus g prime times f. So f prime is 5e to the 5x times g, which is cosine of x squared, plus g prime, negative 2x sine of x squared, times f, e to the 5x. And there's not a lot we can do to simplify here. One thing we can do whenever we have e involved in a product or a quotient rule is that usually we can factor it out, because since e is its own derivative, then we usually end up with it. We do end up with it in both terms. And so I'm going to go ahead and factor that out to the front, e to the 5x, and then I'm left with 5 times cosine x squared minus 2x sine of x squared. And I think that's about as simplified as we can get on that example. Let's look at one last example. F of x equal to 3 sine squared of 6x squared. Now this time, if I look at this function, it's definitely a composite function, and I actually have 3 functions here. I'm going to rewrite this because I've got that squared on the sine function. I'm going to rewrite it and move the squared to the outside. So that would make it 3 sine of 6x squared squared. Put the squared on the outside there. And so we've got 3 functions. I have this squared and the 3 that are the outside function. The next would be my sine function, and finally the 6x squared. So I'm going to do a chart again, but this time we've got 3 functions. The first of them, 3 times something squared. Next is sine of something, and then finally 6x squared. So those are our 3 functions. We're going to do each derivative. My first derivative, we're using the power rule. So 2 times 3 is 6 times something, and then it would be the 2 minus 1 would just be 1. You could put a 1 exponent, but you don't have to. Next up is sine. The derivative of sine is cosine of something. And then finally, the derivative of 6x squared is 12x. And then this something should go in there, and this something should go in there. There we go. So for our derivative, our final derivative, we're going to multiply all of these together. And it looks like I'm going to multiply the 6 and the 12 together. So we got 72, and I'm going to bring that x to the front. Typically, if we have x's, they go in the front, in front of trig functions. 72x times sine of 6x squared times cosine of 6x squared. And that would be our final answer.